Hi guys, my name is Tanishwa, unlike Singer Edwin, and today I'm going to talk about, going to explain to you about our numerical method project. So, as I said before, my name is Tanishwa Singer Edwin, and my teammates are Ruvinder Raj Ravi Selve, unlike Ravi Selve, and Muhammad Hilmi Bejahari. So, title for us today is Interpolations and Newton's Divided Difference. As per our task given, our main topic is to choose a good engineering solution for engineering problems with two correct and punctuating numerical methods to solve the following problems. So for this problem, we took interpolations and Newton's divided difference. So this is me, and this is Mr. Ravindra Raj, and this is my another friend, Muhammad Hilmi Bijohari. So let's move on to the introduction first. So for the introduction, wind energy has emerged as prominent renewable energy source, heralded for its potential to mitigate climate change and reduce dependency on fossil fuels. However, the deployment of wind farms is accompanied by a myriad of challenges and concerns that must be addressed to optimize their benefits and minimize their drawbacks. These challenges include visual impact, noise pollution, ecosystem-related issues, health hazards, impact on tourism and agriculture, reduction in land value, and the complexities of wind turbine waste treatment at the end of their operational life. As we go moves on, we just elaborate them specifically, like for the noise pollution and the visual disturbance, right? It's just a significant source of opposition among residents. Like if there's a windmill over there, the noise pollution that occurs because of the windmill will affect the residential sites over there. If I say uh, the offshore wind farms with located with the households there will literally gives an impact for us because of the sound and the visual disturbances and everything. So typically not more than 18 kilometers from shore to balance efficiency visual impact. So we need to apply at the 18 kilometers, from shore. Shore means from the place where the windmill have been planted to maintain the balance efficiency and the visual impact. And accidents involving wind turbines such as blade failures and fires are not uncommon and increase as more turbines are built. Wildlife is also affected, such as birds and bats, which uh, being collide over the windmills wings over there. Careful site selection and mitigation measures like brightly colored routers and nighttime lighting can help these incidents. So this is a kind of a solution for what we can for the problem that we're facing right now, which is accident in happening because of windmills. Despite general public support for renewable energy, local opposition often arises due to fears of decreased property values and other local impacts. Engaging local communities in the planning and the decision-making process is literally crucial to gaining the support and ensuring successful wind farm projects. End of life management for turbines presents significant challenges, particularly with the recycling of composite material used in rotor blades. Effective recycling methods are still under development, and current options including mechanical recycling, reincarnation, pyrolysis, and landfill disposal, with landfill being the least desirable. The economic viability of the wind energy is also influenced by high initial investment costs, which makes a kind of complex planning and permitting procedures, and the intermittent nature of wind, which affects the grid stability. Strategies such as energy storage solutions and improved wind forecasting can also help mitigate this issue. For project background, our project background is based on an article that we have obtained through the internet. So the scope of the article is to indicate the obstacle of having windmill and the number of accidents and incidents happening until 2015. So from 1996 till 2015. So we have obtained the data for our project from this article, and this article we have given in the reference below here. So and then later you can refer it and read all the article. So moreover, A wind turbine is kind of electrical energy, kinetic energy, which converts the kinetic energy to the electrical energy, which is renewable. And then, and hence, we are required to approximate the cumulative API value in month 4 by using Lagrange and Newton's dividend difference. So later, let's we move on to the methodology. So for methodology is, so what's the main concern of methodology? Methodology is so simple. Methodology is a way, is a method that you classify to make a solution for the problems. So what's the method over there? How you gonna solve it? So what's the method? You're just gonna explain the method, right? So the method explaining is methodology. So a suitable method to solve the problem, and here is the wind turbine accidents which is recorded, and the wind turbine is kinetic energy of the wind, and the global wind resources. These are the researchers who estimated the 72 TW, which is 77 times the world electricity demand and 5 times the world energy demand. And then this project approximates the global cumulative installed wind capacity in 2012 using a quantitative methodology based on Lagrange interpolations and Newton divided difference. So as I said before, we just using Lagrange interpolations and dividend device to find the API cumulative on 2012, and a polynomial that transfers each of the provided data points is created by the Lagrange interpolations. Its base foundation is the multiplication of each data point by a collection of polynomial basis function to create a Lagrange polynomial. The Lagrange polynomial is the result of combining these fundamental functions which are dependent on the other data points. Newton's divided difference, on the other hand, takes a different method to create an interpolating polynomial, which entails using the data point and matching function values to create a table of divided difference. The interpolating polynomial is formed by computing the difference recursively. So as far as we can see, these are the steps to find Lagrange interpolations. So after we find everything, we're just going to substitute with the table that have been given before. So this is Newton divided, Newton dividend divided method, difference method, and these are Lagrange interpolations. So as we can see, these are the formula: fx equals to p1x equals to lox fo plus l1x f1. And then for the second step, we have to calculate quadratic approximation, which pass through the three given points before. So fx equals to p2x equals to LOXFO plus LOXF1 plus L2XF2. So LO is x minus x1 times with x minus x2 over xo minus x1 minus xo minus x2. And same goes to L1 and L2. As we should see before, at the upwards here, if LO there'll be no XO over here. If L1 there'll be no X1. If at X2 there'll be no X2. So similar only. And same goes to the step 3. For the cubic approximation, for step 3, we have to find the cubic approximation. For cubic approximation, same thing we have been given from the previous step, passes through the 4 given points. As we get from here, we got 4 points, right? And the previous 4, we just going to pass through the 4 given points. Before this, we got 3, right? So for and here 4. So like 1, 2, 3, 4. So LOX times with FO, L1X times with F1, and sum with L2X times with F2, and then sum with L3X multiply with F3. So if it's LO, there will be no LO here, XO here, and the formulas are the same formula, but just the enlargement of the formula here. And for the step 4, same as the previous steps, by the quartic approximation will be it pass through 5 given points. So it will be like FO until F4. 1, 2, 3, 4, 5. And then let's move on to the Newton difference method. So we have done for the first method, which is Lagrange interpolations, and let's move to the Newton's difference method. So for Newton difference method, table is a mandatory. Table is so mandatory. So for the table, we have to identify I, I is 5, so like 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, and here will be XO, X1, X2, X3, X4. So for us, it'll be like 2008, 9, 10, 11, 12. And then Fi1, Fi2, Fi3, Fi4 it will be given, and these other some product, it's not some product, it's like it's the way of table using. So as per to find the FO, we have to use this formula, which is F10 minus FOO over X1 minus XO, so that we can get X over here. So same formula applied to get the first FIO to find this, and then move to the second third step, which is to calculate the second Newton's dividend difference, which is to find this labeling. So which is 4, right? So you have to find 3 here, so that we can get 3 over here. So first form is this, and the second Newton's difference is this, and the fourth one is this, which to get 2. So as we seen before, every each step is be decreasing. It will decrease. It keep decreasing 1 point. It will be 1 point again, plus 1 point, and it will be plus one more point here, and plus one more point here. So it'll be like it's kind of you'll miss out with 1, 2, 3, 4. So this I will be given later, and these FO values will be found by our calculation. So as I said before, these four steps of, I mean the four formulas of the first Newton difference will be here, and the second will be here, third will be here, fourth will be here. So these are formula. Same formula applied, and for the final step, after we got the FO4 here, for the final step we have to find Fx equals to P for x equals to FOO plus FO x minus XO plus FO2 x minus XO x minus x1 plus FO3 x minus XO x minus x1 x minus x2 plus FO4 x minus x0 x minus x1 x minus x2 and x minus x3. So let's move to the way on how to analyze and discuss the method. So there are two ways that will be employed to approximate the values based on the selected data. First, we manually calculate the result by using Newton difference method, and then the Lagrange interpolations, or else vice versa. In the meanwhile, we make use of a program called MATLAB. This is the computer software using coding to find out our data over here. Simple only. Once we've done our manual calculation there, we got a result, right, and then we put a coding, and then the MATLAB will make another outcome which results into a more corrective way. So if the both results are same and accurate, it means our data is good lah. Our calculation is good. Our calculations and the data is perfect. That's it. And this will assist us in figuring out which numerical approach will work best to tackle the issue. The interpreting polynomial, which formed by a combination of Lagrange polynomials through a weighted sum, as I said before. The data point of the corresponding interpolation basis function serve as the foundation for these polynomials. Newton's divided approach entails creating a table with the division differences between the data point to find the interpolating polynomial coefficients. While the ultimate objective of the both approaches is to discover an interpolating polynomial, given a set of data points, they vary in terms of computational complexity and strategy, which is MATLAB. Finally, we utilize MATLAB software to confirm whether the results of the manual calculations are equivalent or not, and they are equivalent, and it established that the manual computation is accurate, eh, which is displayed by our MATLAB. It means it's perfect. So that's all from me today, and the result of discussion will be discussed by our friend over there.
Hello, my name is Raj. My matric number is DE220007, and this is the data that used for calculating the interpolations, which is from 2008 until 2013. And we are using Lagrange interpolations for Lagrange interpolations. So to solve the problem of using Lagrange interpolations for the given data points and estimating the value at x is equals to 2012 using linear approximations with 2 points. The data points are 2008, 2009, 2010, 2011, and 2013 for x, and for fx it's 130, 130, 120, and 170 for both 2011 and 2013. So for linear interpolations, we use 2 points that are closest to x equals to 2012, which is closer, very closest to 2011 and 2013. So, so for yeah. So using these points, the linear interpolation formula is fx equals to fx plus fx1 minus fx0 over x1 minus x0 times x minus x0, where x0 is 2011 and x1 equals to 2013. So we will calculate the interpolated value at x equals to 2012. Using linear interpolations with data points 2011 and 2013, the interpolated value is 170, which is x equals to 2012. This makes sense since the y values for both 2011 and 2013 are the same, which is 130. So the interpolated value at 2012 remains constant. And lastly, for to find the error, so we need to minus 170 minus 155, 165. So the error is 5. And for quadratic approximation, we need 3 points that are closest to x, which is 2010, 2011, and 2013. The closest point is 2012. So using these points, we can form the Lagrange polynomial for quadratic interpolations. So we can use this formula, using this formula. And by using this formula, uh, we can find that the polynomial at x is equals to 186.67, and the error is 21.67. And for cubic approximation, we need 4 points that are closest to x, which is 2012. So using these points, we can form the Lagrange polynomial for cubic interpolation. So we can use this formula, polynomial formula, and so we can find that to find the we need to calculate the value of polynomial, which is at x equals to 2012. So to find this so the value is around 210, and the error for this polynomial equation is 45. And for quadratic approximations by using these data points, so x equals to 2012, which is mid-range of 2009, 2000, and 2013. So by using this polynomial formula, so we can get the value for x equals to 238, and the error for the polynomial interpolation is 73. And for Newton's divided different method, so this method is used to construct the interpolation polynomial, and by using the formula from this table for the first divided difference, the value is uh, f0 equals to 0, f1 equals to -10, f2 equals to 50, f3 equals to 0. And for the second Newton's divided difference, by using the formula, we can find that f0 equals to -5, f1 equals to 30, f2 is equals to -16.6667, And for the third Newton's divided difference, we can find that F0 equals to 11.6667 and the F1 is equals to negative 11.66667. And lastly, for fourth Newton's divided difference, we can find that the F0 equals to negative 4.667. So from the first one, we can find that the F0 will reduce from F0 until uh, one by one. For the so we can find the whole fx is we can plus from whole Newton's divided difference. So the total is 238. Thank you.
So, for the simulation of MATLAB, we also using two methods, which is Lagrange interpolation and Newton differentiation. And the first one is Lagrange interpolation. We use the MATLAB to find the approximation of linear, quadratic, cubic, and quartic. And as we can see the coding, uh, the first thing we do is to to input the year and the number of accident, and then the range of point of interpolate, which is 2012. And then follow to below, we input the coding to find the linear approximation 2 point, follow to quadratic approximation 3 point, cubic approximation 4 point, and then the last one is quartic approximation 5 point. And then if all this coding done, we get the result at each approximation, which is at 2012. For linear, we got 170. For quadratic, we got 186.67, followed for the cubic 210, and then the last one quartic is 238. And then we follow to the second method, which is Newton divided difference. Using the same method as the previous, we input the year, we input the number of accident, but we change the coding for the language to Newton divided difference. And then as the coding is done, we got the result for the coding here, which is the table, and then the result for 2012 is 238. And then we move to the discussion. For this project, we approximate the accident and incident involving wind turbine in 2012 using Lagrange and Newton divided difference. And then we calculated using two methods, which are manual calculation and MATLAB simulation, to confirm the result is accurate. And then from the calculation, we acquired that MATLAB data indicate the simulation value and the manual calculation value for Lagrange and Newton divided difference are identical, and as the result, the accuracy of the result calculated is established. And then move to the conclusion. Our research into interpolation technique, particularly as it relates to Newton divided difference method and the Lagrange interpolation theorem, has produced significant new insight into the process of approximating mathematical expression based on discrete data point. The remarkable versatility of the Lagrange interpolation theorem was demonstrated for both equally and unequally spaced database, by making it easier to design polynomials that smoothly flow over given data point. And the difference computational method for determining coefficient for interpolating polynomial was provided by Newton divided difference method, which involving generating a difference table. The laborious procedure of manual computing this interpolation was greatly enhanced by the comprehensive verification tool of MATLAB, and they give us opportunity to double check our finding and give us assurance regarding the accuracy of the interpolation method we employed. And it is demonstrated that our hand calculation is accurate because it yields the same result whether run through MATLAB simulation and our manual calculation. And as we proceed, it becomes relevant that the interpolation approach works well not only in academic but also in real-world contexts where problem solving is required. Further consideration could involve a more true examination for different interpolation strategies, and then they're tailored for specific circumstances, as well as continuing evaluation and emerging computational tools and algorithms that could further enhance and optimize interpolation process. Our study emphasized the significance of the interpolation technique as we studied in approximating values, making them indispensable tools for resolving real-world problems in range of academic domains. That's all from me.